Okay, so welcome everybody to math lesson number 2. Today we're going to go through all of 1B. So there's 1B, 1, 2, 3, 4. They're short, sharp, shiny, and it's all stuff we have done before, apart from when we introduced natural logarithms, which we've briefly discussed at the end of last year. So firstly, we're just going to, so 1B is all about logarithms and operations with logarithms. So firstly, we're just going to have a bit of a recap about what logarithms mean, or what it means to say log of 100 or something or other. So firstly, we're going to start with the graph y equals 10 to the power of x. Okay, that's what it's going to look like here. And we can see when x is 0, y is 10 to the power of 0, which is 1. 10 to the power of 1 is 10, 10 to the power of 2 is 100, and it grows exponentially. Okay, that's the graph of y equals 10 to the x. So we should remember, right, if I'm to say what is log of 100, okay, well that's going to be log of 10 squared. And now because we've expressed this as a power of 10, we can simplify it to the integer power, okay, which is 2. So if I'm to say what is log 50, okay, what does that mean? If you put that in your calculator, you get 1.69, all right, with other decimals, there's infinitely many. And that means, okay, what that means, if we have log 50 equals 1.69, okay, that's a logarithmic statement. The exponential statement is 10 to the power of 1.69 equals 50. Okay, 10 to the power of 1.69 equals 50. The reason is the logarithm here is in base 10. Alright, so that's what logarithm means. If I say log 720, okay, and you calculate that in your calculator, it means 10 to the power of what equals 720. That's what that value will signify. So here we have a logarithmic statement, question 1. Given a logarithmic statement, write an equivalent exponential statement. Okay, so here the base is 10. So the exponential statement is going to be 10 to the power of 2 equals 100. Okay. In B, the base is 3. Okay. So that means the exponential statement is going to be 3 to the power of minus 2 equals 109. Now we're not unveiling anything outrageous or fantastic here. This is all a straightforward connection that flows from these two. In question 2, we're asked to do the opposite. We're starting with an exponential statement, and we are now going to write a logarithmic statement. Here my base is 10, okay? So my logarithm statement is going to be log of 1 on 100 equals minus 3. Now that should be minus 2, guys, unless let's put another 0 there. Log of 1 on 1,000 is minus 3. Okay, now we could unpack how this is true, right? We can unpack how it's true. So let's revise that quickly and I'll write it out in a moment. If we have log of 1 on 1,000, we can write that as log of 1 on 10 to the 3, which is log of 10 to the minus 3, which is minus 3. Once we express it as a single power of 10, we can simplify it to the integer. So this is obviously a true statement. Here I just unpacked how we can put some more steps in to illustrate its truth. Okay, here we have an exponential statement. The base is 2, which means the base of my logarithm is going to be 2. So I'm going to say the logarithm in base 2 of 16 is 4. This is another one that we can illustrate to be true as well. We can express log of base 2 of 16 as 2 to the power of 4. Alright, and then we can see that because we've expressed this number as a single power of 2, it would simplify to be 4. Okay, so that's one that's clear. Let's move on to question 3. In 3, we are asked to simplify logarithms using their rules. So we're going to get right into practicing what we were just doing. We need to express this number as a power of this base. All right. Here it's already done for us. We have log in base 5 of 5 to the 1. 5 by itself is 5 to the 1. This simplifies to 1. We have log in base 2 of 32. That's going to be log in base 2 of 2 to the 5. Now, we said this last year, we should know the first 5 powers of 2, 3, and 5. Okay, we should know it. We've expressed it as a single power of 2, so that's going to simplify to 5. Okay, let's move up here to C. We've got log of 1 on 100. There's no base written there, which means the base is 10. So we need to express this number as a power of 10. We've got log of 1 on 10 squared, which is log of 10 to the minus 2, which simplifies to minus 2. Okay, log in base 3 of root 3 on 9. We need to collect these. We need to express it as a single power of 3, which means we need to use index laws. So this is 3 to the half on top of 3 squared. Okay, that's our first step. Next, we have the top power take away the bottom power. So it's still log in base 3 of 3 to the half take 2. Alright, now that fraction operation, we do sort of expect you guys to know how to do those things, okay? Either in your head, or working it out manually. Alright, we will do some more as we're going along, but pretty basic one. And the other thing is you can use your calculator to help you out here, but you're not going to have your calculator in your first test. Okay, but for every test following that in the exam, you will have access to your calculator. But let's know these things, okay? That's going to be 1.5 minus 1.5, which is minus 3 on 2. Okay, we have expressed it as a single power of 3. So now, because 3 is the base, it simplifies to minus 3 on 2. Alright, looking at E, the answer is not immediately apparent to us. We're trying to find some link between base 5 and 0.2. And this is one that sort of you just get better at the more you see it. So this is log of 1 on 5. Sorry, log in base 5 or 1 on 5. 1 divided by 5 is 0.2. Which is log in base 5 of 5 to the minus 1, which is minus 1. All right. Let's move on to question 4, where we're using the laws of logarithms to express these as a single logarithm. So the laws of logarithms are listed at the top of your page there, and we can see if we have log 2 plus log 10, it becomes log of 2 times 10, which is log of 20. Okay? So if you go into your calculator, you put log 2, and you go plus log 10, you'll see that it is equal to log of 20. Okay, when we're subtracting, it is the first one divided by the second one. So it's going to be log of 120 on 6, which is also log of 20. Okay, so here's another link. You put log 2 plus log 10 in the calculator, you will see it is equal to log of 120, take log of 6. Okay, in C, we have log in base 2 of 5 plus 3. Okay, we can't just go 5 plus 3, that's 8. Okay, we can't do that. We first need to express this number as a logarithm in base 2. Okay, so I'll show you the first step and we'll make a link there. We're going to have log in base 2 of 5 plus log in base 2 of 2 to the power of 3. Okay, this term remains. This term, if you are to simplify it, it simplifies to 3. So we're just going back the opposite way. We're expressing it as a logarithm. Okay? So if that step's a bit confusing, put an asterisk there, but we have seen it before. Let me know when I'm coming around. So then we've got log in base 2 of 5 plus log in base 2 of 8. 2 to the power of 3. 2 times 2 times 2. And now we can collect those together. That's going to be log in base 2 of 5 times 8, which is log in base 2 of 40. Okay, in D, we have 3 log 2 plus 2 log 3. Now we can't just add them together straight away or perform the rule because we have these numbers out front, so we need to deal with them first. And so we're going to use the power rule, where we can take that number out front and make it a power there. So the next step is going to be log 2 to the 3 plus log 3 to the 2. Okay, so I'm just moving those powers out the front. Both are still in base 10. That gives us log 8 plus log 9. We can now collect that. Okay, now looking at this one, I can see a number of ways we can solve this one. I'm going to show you 2 paths, 2 potential paths. So it just says simplify, right? So one thing we can do is we can recognize these have the same base, 9 and 81. In fact, what we have is we've got one lot of log in base 3 of 9 on top of log in base 3 of 9 squared. Okay, 9 squared is 81. So that would be the first step. And then in the next step, I can bring that 2 out the front. So I have one lot of log in base 3 of 9 on top of 2 lots of log in base 3 of 9. Okay? And all I've done is brought the 2, 9 squared is 81, brought that 2 out the front. Now you can see we've got log in base 3 of 9 on top of log in base 3 of 9 as a product because it's multiplying all of the top and all of the bottom. It can cancel. And so we're left with half. All right, if we put this in our calculator, it'll spit out half. Here we've illustrated how it's true. Okay, another procedure to show the truth of this is by putting them in base 3. Okay, we have log in base 3 of 9. Well, we could write that as, now I might draw a line here, it might even come down here. Log in base 3 of 3 squared, okay? On top of log in base 3 of 3 to the power of 4. 3 to the power of 4 is 81. Now we have expressed both the numerator and the denominator, the top and the bottom, as a power of 3. So now it's going to simplify to the integer that it is. We're left with 2 on 4, which is half. Okay, so either of those processes would be fine for showing that this is true. We'll stop there. Let's answer 1B.1, 1B.2, and then we'll come back a bit later to do 3 and 4.
Thank you.